Hello students, this is a video on the topic test for quant available on Bodhee Prep. The tests are designed to help you evaluate your preparation for a topic. So once you've completed the concepts of a topic, you can take these tests to understand whether you're able to apply those concepts in an exam format or not. With every test, there is a video. So once you take a test, you go through the video. This video is to help you, gives you a brief analysis of what could have been a good attempt in terms of time and the number of questions that you should have looked at. There are more than 200 such topic tests and videos available on the Bodhee Prep app. The link for the app is in the description below. So make sure you download the app and make the most of these tests. This specific video is on progressions. The fourth test on progressions is the topic of this video. If we look at the overall test, again, a moderate level of difficulty test, about 6 questions net correct in this kind of a test would give you a 95 plus percentile. Attempt time for this test would be slightly on the higher side, maybe 23 odd minutes, to go through all the questions and find out the 6 questions that we do and actually solve those 6 questions. If we look at the questions, the first one says the mean median mode temperatures of the 7 days of a particular week in a city are 5.429. Now, this 5.429 is a number that probably I don't know, 0.429 would be 3 by 7. Now, this is a number that I remember, or we would have remembered this number by now, the basic application of percentage. And therefore, we can say because mean or average is 5.429, the sum of temperatures would be 5.429 into 7. 5 into 7 is 35, 3 by 7 into 7 is 3, so this becomes 38. The median is 7. So if we arrange the 7 temperatures, 1, 2, 3, 4, 5, 6, 7, in ascending order, we will get 7 in the middle. Median is 7, mode is 9. Also, the temperature in each of the 7 days was positive integer. Which of the following could not be the temperature or any of the 7 days? All the values are positive integers, so we will not go for 0 or negative values. Also, the 3 values on the right of 7 will be higher than 7. The 3 values on the left will be lower than 7 because the numbers have been arranged in ascending order. Now, the mode is 9. Therefore, there have to be at least 2 entries for 9. Suppose we put 9 and 9 here, and then a value which is more than 9, minimum possible value is 10. Now, if we add the numbers, we will get 9 and 9, 18, plus 7, 25, and 10, 35. 35. The sum is 38, so the last 3 numbers have to be 1, 1, 1, which will make the mode as 1 and not 9. So this case is wrong. I look at the second case, 1, 2, 3, 4, 5, 6, 7, where 9 and 9 are the larger 2 values, and this value is suppose 7 or 8. We'll look at both the cases, 1, 2, 3, 4, 5, 6, 7, 9, 9, 8, and 7. These are the possibilities. Again, 7 and 7 will not happen because then the mode will not be 9. 9 and 7 both will be mode, so this can be rejected. If we look at this case, 9 and 9, 18, 18 and 8, 26 and 7, 33. So the sum of these 3 numbers has to be 5. The only possibility for 5 will be 1, 2, and 2. With 1 and 1, or 1, 1 and 3. 1 with 3 and 3 will. So these are the 2 possibilities. Now in both the cases, here we see that 2 appears twice, so 2 also becomes the mode. Here 1 appears twice, so 1 also becomes the mode. And therefore the only possibility for this case is that 7 is the median. All the 3 numbers after 7 are 9. In this case, 9, 9, 9, 18 and 7, 9, 9, 9, 27, 7, 34. The sum of the other 3 numbers is 4, which can only happen with 1, 1 and 2. In this case, the median is 7, the mode is 9, the sum is 38, so the mean will be 5.429. The data set contains only one mode was mentioned. So the question is which could not be the temperature on any of the 7 days. The temperatures could be 1, 2, 7, and 9. It cannot be 3 on any of the day, and therefore option B. I will call it a difficult question because mean, median, mode, or median and modes are not topics where all of us will be equally comfortable with. And therefore, difficult question, 2 to 2.5 minutes, easily to solve this question because cases will be formed. The sum of three numbers of an arithmetic progression is 12. Arithmetic progression sum. So we can say a minus d, a and a plus d are the three numbers. And therefore, as we can see, the sum of these three numbers will be 3a. This is given as 12. So a becomes 4. This is one of the numbers. And the sum of their cubes. So a minus d cube plus 4 cube plus a plus d cube is equal to 408. Therefore, a minus d cube plus a plus d cube is equal to 408 minus 64. So 408 minus 64, which will be 344. Now 344 I know is 1 plus 343, which is 1 cube plus 7 cube. The numbers are pretty obvious. Or we could have expanded and then tried to solve, but I think here the number becomes very, very obvious. And therefore the three numbers are simply 1, 4, and 7. The sum will be 12. The sum of cubes will be 408. What is the smallest number? 1 becomes my answer. I think easy question, not more than 90 seconds to solve the question. Something that you would want to have in the exam. In a sequence of 100 positive integers, the sum of any 6 consecutive terms is same. What does this mean? If you look at the first 6 terms, A1, A2, A3, A4, A5, A6, and A4, A5, and A6. This will have some specific sum. The sum of A2, 3, 4, 5, 6, and 7 will be the same as A1, 2, 3, 4, 5, 6. Therefore, we can say A1 and A7 have to be same. Similarly, the sum of A2, 3, 4, 5, 6, and 7 is the same as 3, 4, 5, 6, and 8. So A7 and A8 have to be the same, and so on. So basically, the progression of the series will be such that terms will repeat after a cycle of 6, so that whenever we pick any 6 consecutive terms, we get the same values. If the value of 11th, 22nd, 33rd, 44th, and 55th term are 11, 22, 33, 44, 55, which of the following is definitely true about the sum of the 19th and the 99th term? Now, if you look at 6 consecutive terms, 1, 2, 3, 4, 5, 6, the number of this term has to have a remainder of 1 when divided by 6. Here the remainder will be 2, here the remainder will be 3, here the remainder will be 4, here the remainder will be 5, and the sixth term will be a multiple of 6 if we are looking at the first 6 terms. Now 11th term means divided by 6, remainder of 5. Therefore, the fifth term is 11. 22nd means 6 divided by 6, remainder is 4. So the fourth term is 22. 33 means remainder of 3 when divided by 6. So this will be the third term, which is 33. 44 means 6 sevens are 42, remainder of 2. So the second term will be 44. Yes. 55 means 6 nines are 54 plus 1, remainder of 1. So the 55th term or the first term will be 55. Which of the following is definitely true about the 19th and the 99th term? Again, if we divide 19 by 6, we get a remainder of 3. Therefore, A19 will also be equal to A3, A1, not 3. Remainder of 1. A19 will be equal to A1 here, which will be 55. 99 will be A3. If you divide 99 by 6, remainder is 3. So A99 will be equal to A3, which is 33. The sum of these two numbers will be 88, less than 60, greater than 59, less than 76, greater than 75, less than 90. Option C becomes my answer. I think easy question. Should not take more than 2 minutes to solve. The only challenge is to understand that the terms will repeat after every 6 terms. A1, A2, A3 are in AP. 1 upon root of A1 plus A2 upon plus 1 upon A2 plus A3 and so on. They are in AP. Again, for these terms, the first thing that we do is rationalize. Therefore, this can be written as assuming that A1 is the largest term, AN plus 1 is the smallest term. Root of A1 minus root of A2, multiplying and dividing by the conjugate becomes root of A1 square minus root of A2 square plus 1 upon root of A2 minus root of A3 upon root of a2 plus root of a3 into root of a2 minus a3, a plus b into a minus b, root of a2 square minus root of a3 square, and so on. The last term will be root of an minus root of an plus 1. This will be root of an square minus root of an plus 1 square. This is nothing but root of a1 minus root of a2 upon a1 minus a2, which will be nothing but the common difference. Suppose the common difference here is d, plus a root of a2 minus a3 upon a2 minus a3. Again, a2 minus a3 will be the common difference of the two consecutive terms, and so on. Root of an minus root of an plus 1 upon a2 an minus an plus 1. All of the terms in the denominator will become the common difference d, and therefore the numerator will be root of a1 minus a2 plus root of a2 minus root of a3 and so on, till the last terms are root of an minus root of an plus 1. So these terms will cancel out, a2, a2, a3, a3 and so on, and we'll be left with root of a1 minus root of an plus 1 upon d. Again, if we rationalize this and multiply the numerator and the denominator by root of a1 plus root of an plus 1, in the numerator we'll get a minus b into a plus b, which is a square minus b square. And therefore this will be nothing but a1 minus an plus 1 upon d into root of a1 plus root a plus 1, an plus 1. Now the difference between a1 and an plus 1 will be n times of d, because an plus 1 is nothing but a1, if a1 is the first term, plus n minus 1, n plus 1 minus 1, n plus 1 is term, or a1 plus n d. So the difference between these two, an plus 1 and a1 will be nd. So nd upon d into root of a1 plus root of an plus 1. D and D cancel, and therefore the answer that we get is option B, n upon a1 plus root of an plus 1. Now, for this kind of a question, the process is standard, and therefore I'm saying conceptually moderate level of difficulty. The attempt time, because of writing, increases, but otherwise should be somewhere around 2 to 2.5 minutes. Marks of 7 students form a geometric progression. The marks of the students, if the marks that the students got were all distinct integers, and the maximum marks that any student could have got is 100. Which of the following could be the marks of one of the students? Now, since all of them are distinct integers, the common ratio has to be an integer as well, and the smallest number, which is not 1, so that the values are distinct, the smallest ratio possible is 2. 2 raised to power 2, 4, 8, 16, 32, 64. There are 7 people. 2 raised to power 6 is 64. Anything beyond this will cross 64, and therefore what we are saying is the marks could be such that the first student scores 1, 2, 4, 8, 16, 32, and 64. These are 7 numbers, 1, 2, 3, 4, 5, 6, 7. 7 students, geometric progression, distinct integers, maximum marks less than 100, and therefore the marks of the students could be, one of the students could be 64. And this is an easy question, not more than a minute and a half to solve. Let x, y, z be 3 positive real numbers in geometric progression such that x is less than y is less than z. If 5x, 16, y, and 12z are in arithmetic progression, now we can say that x, y, z can be written as x into r, common ratio, x into r square, x, y, z. R being x is less than y, r being greater than 1. So that x is less than y, which is less than z. Now 5x, 16y, and 12z are an arithmetic progression. So we can say that 5x plus 12z will be equal to 2 times of 16y. If A, B, C are an AP, A and C, B is the arithmetic mean of A and C. Therefore, A plus C upon 2 is B, or A plus C is equal to twice of B. So 5x plus 12z becomes 12x r square plus 32y is equal to 32y. So 32 into xr. X gets cancelled. So we get 12r square minus 32r plus 5 is equal to 0. So we're looking for two numbers which have a product of 60, 12 into 5, and a sum of 32. So 30 into 12r square minus 2r minus 30r plus 5 is equal to 0. 2 common, 6r minus 1 minus 5 common, 6r minus 1 is equal to 0. This is 2r. So 2r minus 5 into 6r minus 1 is equal to 0. So either 2r minus 5 is 0, which means r is equal to 5 by 2, or 6r minus 1 is 0, which means r is equal to 1 by 6. We know that r is greater than 1, so that x is less than y is less than z. So we will eliminate this option. The common ratio of the geometric progression will be 5 by 2. Option C becomes my answer. I think moderate sort of a level question. Solving a quadratic by writing an equation should take about 2 to 2.5 minutes. S1 is a set of numbers 2, 4, 6, 8, 10, multiples of 2 essentially. S2 is a set of numbers 3, 6, 9, 12, and so on, multiples of 3. If S3 is union of S1 and S2, what will be the 105th element of S3 if all the elements are arranged in ascending order? Now, if we write elements of S3, we will have 1 will not be there, 2, 3, 4, 6 will not be there, 5 will not be there, 6. Then 7 is not there, 8, 9, 10, 12. Then we'll have 13 is not there, 14, 15, 16, 18. So if you look at 6 numbers, 1 to 6, there are 4 elements here. 7 to 12, there are 4 elements in S3. 13 to 18, there are 4 elements in S3. Similarly, after 18, 19 will not be 20, 21, 22, 24. Again, 4 elements in S3. 3 multiples of 2 and 1 multiple of 3, or 2 multiples of 3. With one of them being common. So out of 6 numbers, out of every 6 numbers, there will be 4 numbers which will be in S3. Now we need 105 terms. The product of 100 or a multiple of 4 less than 105 is 24. It is 104, which is 4 into 26. So if we write 4 into 26, if we multiply 6 into 26, you'll get 156. So if we write numbers from 1 to 156, these are 26 groups of 6 numbers. Out of these, 4 numbers from every group will be chosen, and we will have 104 numbers of S3. The next number that we write will be a number which will be the 105th element of S3. 157 will not be S3 because not divisible by 2 or 3, and therefore 158, when we write, becomes the 105th element of S3. I'll call this question a moderate to difficult level of question. Getting that pattern might be a bit of a challenge. Once you have the pattern, takes about 2 to 2.5 minutes to solve. If the sum of the first 11 terms of an arithmetic progression equals that of the first 19 terms, so A1 plus A2 plus A3 up till A11, this sum is the same as saying A1 plus A2 plus A3, A11, A19. These two sums are the same. So we can say that the sum of terms from A12 to A19, A12, A13, A14, A15, 16, 17, 18, 19. This sum is 0. This can only happen when the first 4 terms are negative of the last 4 terms. Therefore, A15 has to be equal to minus A16, A14 has to be equal to minus A17, and so on. And therefore, by that logic, we can say A1 to A15 terms will be negative signs of the next 15 terms, that is A16 to A30. For example, if we say that this is 1, 3, 5, 7, and so on, this has to be minus 1, minus 3, minus 5, minus 7, and so on. So the first term here, A1, will be 1, 3, 5, 7, 2n minus 1. So 15, 2n minus 1, 29, 29. And the last term here will be minus 29. What is the sum of the first 30 terms? When we add the first 30 terms, the sum will come out to be 0. The first 15 terms will be the negative of the last 15 terms. Or we can always say that the sum of the 30 terms will be a1 plus a30 into 30 by 2. First term plus last term into n by 2. And from here we know that a12 to a19 is 0. And therefore a15 plus a16 has to be 0. A15 plus a16 will be equal to a1 plus a30. And therefore the required sum of the first 30 terms is 0. Easy question. You would have come across this kind of a question while practicing as well. Whenever a set of terms is 0, either the middle term of that or the sum of the two terms in the middle is 0. And therefore we'll have opposite signs on each side of that term. If in an arithmetic progression, the 12th term is 23 7 by 29, 64th term is 136 22 by 29, the sum of the first 75 terms. The sum of the first 75 terms will be n by 2 into 2a plus n minus 1 d. This is nothing but 75 by 2 into a plus, I'm trying to break it down into these terms, 11d plus a plus, here we will be left with 63d. This is nothing but the 12th term. This is nothing but the 64th term. And therefore the sum is simply 75 by 2 into the 12th term, which is 23 7 by 29 plus 136 22 by 29. This is nothing but 75 upon 2 plus 23 plus 36, 136 plus 7 plus 22 upon 29, which becomes 75 by 2 into 159, 160, 160 by 2. This becomes 80. 0, 8, 5, 40, 0, 4, 8, 7, 56, and 460. So 6,000 becomes my answer. Again, I think easy question. We just have to add the terms and multiply by n by 2. Also, while adding, it's a mixed fraction, so we separate the integral and the fractional part and add them. 136 plus 23, 150, 160 into 75 by 2 becomes my answer. The first term, 7th term, and 31st term of an increasing arithmetic progression, d is greater than 0, are in geometric progression. Find the ratio of the first term to the common difference. The first term is a, the 7th term will be a plus 6d, the 31st term will be a plus 30d. These three terms are in geometric progression, so we can say a into a plus 30d, root of this is equal to the second term, which is a plus 60. When a, b, c are in arithmetic progression, a and c, b is the geometric mean of a and c, so if we square, we get a into a plus 30d is equal to a plus 60 whole squared. So a square plus 30 into a into d is equal to a squared plus 36 d squared plus 12 into a into d. A square cancelled. Negative we are getting. This further means 12 AD on the other side, 30 minus 12. 18 AD is equal to 36 D square. 18 2s are 36. Since it is increasing, D will not be 0. Therefore, A is equal to 2D. What is the ratio of the first term to the common difference? A upon D, therefore, will be 2 by 1. Option B for us becomes the answer. Again, I think relatively easy question, about 2 to 2.5 minutes to solve. So if you look at the overall test, moderate level of difficulty, 6 questions we're looking for, about 23 minutes to solve. My 6 questions will be 2, 4, 5, 8, 9, 10. Which are these? Not counting this one because there are median and mode and median involved. This, I think, definitely doable. Simply by putting values, we get the answer. Again, might find a little challenging to crack this question. So not counting this per se. This is a standard process, rationalize, add, finish the question. This also, I think, was pretty simple because the only common ratio possible was 2, and the options were also simple. This question, again, not very difficult, but there are there was a quadratic which was giving us two values. Chances of confusion, so not counting this outrightly. This one I'm not counting because, again, looks straightforward probably, but until you crack the pattern, you'll not be able to, at least I will not be able to solve the question. And depending on the type of numbers or sets given in the exam, the pattern might not be so easy to crack. So not counting this as an easy question or something that I can repeat every time. This, I think, was a straightforward question. I have done these questions earlier as well. Similarly here, similar questions have been done earlier. Simple calculation. Here also I'm counting this question because again, there was no quadratic formed. D square cancels out, A square cancels out, D and D also cancel out. So pretty straightforward calculation there was left. And therefore my 6 questions will be 2, 4, 5, 8, 9 and 10.